A lot of people get super confused with this one. Fact is, it's so easy that you may get confused, right? We are dealing with the composite function here, which means you have f of x, g of x, and you're plugging in the f of x into the g of x. So you're plugging in the f of x into the g of x, right there where the x is at. So if we actually did that, we're going to end up with 6 on top over the square root of x minus 2, and then plus 3, and on the outside a plus 1 completely separate. Now, I don't know if you guys remember back when we did the radicals section of this class, we said we didn't want to leave square roots in the denominator. We did not. And we would have to multiply by the conjugate, both top and bottom, by the conjugate of that binomial square root of x minus 2 plus 3. So you'd have to technically multiply this bottom one by the square root of x minus 2 minus 3, so it'll cancel out all radicals. But we're not going to do that. Why not? Because the answer is right there. They didn't even simplify it. They just left it like that. Now, if it was an open response test and we were doing this as one of our regular tests here, I would expect you to get rid of the radical in the denominator. They obviously didn't do that. Now, you might be thinking, what's this other piece over here? X has to be greater than or equal to 2. Well, that's the part where it says, and state its domain. Okay? Now, what does that mean? It means state the values that the inputs can be. So, if you think about the square root function, if that whole x minus 2 becomes less than or equal to less than 0, then it would be negative, which would give you an imaginary number. So, I mean, even on the original, you could think of the f of x. If your x was less than 2, then it would produce a negative number in there, right? Or you could think of it the way I recommend you think of it. X minus 2, let me write this right here on the side. X minus 2 has to be greater than or equal to 0. And when you solve it, x has to be greater than or equal to 2. Okay? So that's what this is talking about. It's talking about the domain. Now, you didn't even have to work out that domain because this is the only one that has f of x plugged into the g of x function. So, let's try number 54. That one has logarithms. It has both log base 2. That's a good thing. Because when you have the same logarithm on one side, of the equal sign, you could condense and make it one single logarithm. Now, we are going to be using the quotient property because of that minus sign. So again, I'm going to take the log base 2 and the log base 2 and write one single log base 2. And I'm going to take the x to the 10th and put it over x to the 7th. So x to the 10th over x to the 7th. So you really have log base 2 of x to the 10th over x to the 7th. Let me put that 7 in a different color. And it's still equal to 46, so don't forget that part. And we could simplify the x to the 10th over x to the 7th. All 7x's cancel with 7 of these, and you're going to have 3 left over. So what we really have is log base 2 of x to the 3rd equals 46. So at this point, you got to think of your other properties. We used the quotient property because of the minus sign. We could also use the power property because I have a power right here. And the power property says when you have a power on a logarithm, you could take that power and write it as a regular number being multiplied by the logarithm. So I'm going to take the 3 and put it out in front. So it's going to be 3 times log base 2 of x equals 46. And of course, we're solving for x. You want to get x by itself. So I'd have to get rid of the multiplication of 3 by doing the opposite, dividing by 3. What you do to one side, do to the other. And so what we have left is, and I'm running out of space here, what we have left is log base 2 of x equals 46 over 3. We're going to leave that as a fraction. Now, I still want to solve for x. I need to get rid of that log base 2. And I hope you guys remember back when we were solving logarithmic equations, to get rid of a log, you do the opposite of a log, which is really moving it up to be an exponent. Exponential is the opposite of a logarithmic. So to get rid of the logarithmic, we're going to make it an exponential. In other words, what I'm saying is I want to make this whole side to be the power of base 2. So I really have 2 to the power of log base 2 of x. And what I do to one side, I do to the other side. So on the other side, I'm going to have 2 to the 46 over 3. And we're going to ignore that equal sign up there because those are now exponents. Now what happens with the 2 to the log base 2, it cancels out and the x comes down, the equal sign comes down, and you really do have 2 to the 46 over 3. Now we could simplify that, but before I get too far into simplifying that, let me go back to my answers and see what they have it as. And they actually leave it like that, 2 to the 46 thirds power, which is option D. Now let's say this was an open response test. You could have actually taken the 46 divided by 3, and then you'd have a mixed number. Actually, let's do it. So 46 into 3, you'd have 15 and 1/3. So if you did go 46 divided by 3, you'd get 15 with the remainder of 1. That's where I got the 15 and 1/3. And then technically you could split that to 2 to the 15th and you get a huge number. And then times 2 to the 1/3, which is actually the third root of 3. So you could express this as a radical expression also. But of course, for the final, they leave it like this. X is equal to 2 to the 46 over thirds power. Okay, let's move on. So if you understood 54, you should be able to do 55, and we are now moving on to the last page of the final review. Number 56, capital F-U-N, fun. Okay, the deal right here is you have an equation, you want to solve it, and I notice that the 64 and 16, when I think of 64 and 16, for some reason I think of the base 4, because each of those could be rewritten as 4 to a certain power. So that's what I'm going to do. Instead of, let me zoom in a little. Instead of 64, I'm going to write down 4 to the third power. That's 64 right there. And don't forget, we still have the x plus 5 on the outside. We still have the equal sign. And instead of 16, I'm going to write that as 4 squared. And you still have the outside power of x. Now, when you have a power to a power, you multiply. So we'd have to distribute 3 times x, 3 times 5, and you would get 4 to the 3x plus 15 power equals 4 to the 2 times x, that's 2x power. And now that we have the same base 4, we could eliminate the 4's. And the reason for that is because technically you could apply a log base 4 on both sides. Now that really is a waste of time because you're going to cancel them out anyway. So you can just cancel out the 4's and you're going to have a new simple equation that says 3x plus 15 equals 2x. And if we continue to solve, I want to move the 3x over to the other side, subtract 3x, subtract 3x. You're going to end up with 15 equals negative x, which means that x equals negative 15. And that is option B right there. And if you understand number 56, you should be able to do 57 on your own. Let's try number 58. 58, again, it's solve. And again, we could look at these bases and we should think, could I change them to be the same base? And the answer is no, you can't, right? Because 6 to what power gives you 60? It doesn't work. So you can't really do that. So we go on to our next thought. I need to get x by itself on one side, and x is up here on the exponent position, I don't want it as an exponent. I want it to be a regular 2x. I don't want it to be an exponent. So the way to get rid of something is to do the opposite. And what is the opposite, what is the inverse of an exponent situation? A logarithm situation, right? So what I'm going to do is I'm going to apply a log base 6 to both sides. Let me first rewrite it. There it is, 6 to the 2x equals 60. And like I said, I'm going to apply a log base 6 right there and a log base 6 over here. So that cancels out, and I end up with my new left side of the equation that says 2x equals log base 6 of 60. Now, log base 6 of 60 you can't do. And if you look at your answers, all of them have either ln's or logs. So let's continue to get the x by itself and then apply the change of base formula to find those answers. So let's divide by 2 to get x by itself. Divide by 2, and you're going to get x, and this is technically your answer, log base 6 of 60 divided by 2. Now, log base 6 of 60, we need to be able to find an answer to this, and I need to sneeze. Oh my goodness. Hey, wait a minute, I recorded that. Oh no. Okay, sorry about that. Anyways, let's focus in on the numerator part. Now, log base 6 of 60, you could rewrite that with logs or ln's. I want to go with ln. I don't know if I'm doing the right thing, but change of base formula says ln of the bigger number 60 over ln of the smaller number 6. That's what we have on top, really. And then we could simply divide that answer by 2 and see if that gives us the answer. So, what's happening here is normally we'd get a decimal answer, but we see that none of these answers are in decimal form. And I do see the answer already, it's just written a little differently. Instead of saying this fraction divided by 2, they're saying ln of 60 over 6, ln of 6, sorry, divided by 2. Now, what's the difference, or what is divided by 2? It's really a multiplication of half, right? So, if I were to rewrite this as ln of 60 over ln of 6, and then actually multiply it by 1/2, I'd get the answer that we see right here. ln of 60 over ln of 6, but the 2, they wrote it right in front to make it look like 2 times ln of 6. So the correct answer is B. I hope that makes sense.